Hepatitis is an inflammation of the liver. Your liver is the largest and most metabolically complex organ in your body and performs over 500 functions. Within the thousands of lobules in the liver are the chief functional cells called the hepatocytes, which make up 70 to 80% of the liver's mass. Some very important functions they perform include the detoxification of the blood and the production of bile, which is created by combining the bilirubin pigment from red blood cell degeneration with bile salts. When most of us think about hepatitis, we think of the viral forms, which include the commonly known hepatitis A, B, and C. But did you know there are other forms of hepatitis? These include toxic hepatitis caused by chemicals, autoimmune hepatitis, neonatal hepatitis occurring in infants, and today we will discuss alcoholic hepatitis. Alcoholic hepatitis is inflammation of the liver caused by drinking alcohol. When excessive drinking occurs, the liver cells can be damaged and cell death can occur. Most cases of alcoholic hepatitis occur in people who drink heavily over many years. However, the relationship between drinking and alcoholic hepatitis is complex. What we mean is, not all heavy drinkers develop hepatitis, and the disease can still occur in people who drink only moderate amounts of alcohol. Alcoholic hepatitis is a form of liver disease and can manifest in both acute and chronic conditions related to alcohol consumption. With repeat attacks, it can lead to liver cirrhosis. As mentioned previously, the liver is important for many reasons, including metabolizing ethanol. Alcohol first enters the mouth and travels down the esophagus to the stomach and intestines, where it is first absorbed into the bloodstream. Alcohol is distributed throughout the body and travels to the liver where it is processed. Only certain amounts of alcohol can be metabolized over a length of time. The liver is responsible for continuously detoxifying alcohol and converting it from its original ethanol state into acetaldehyde, a highly toxic substance and known carcinogen, which is then metabolized into acetate, which is then broken down into water and carbon dioxide for easy elimination. This conversion can occur in one of three pathways. The first pathway involves the CYP2E1 enzyme in a microsome. The second pathway involves the enzyme alcohol dehydrogenase, or ADH, in the cytosol. And lastly, the third pathway uses a catalase inside an organelle called a peroxisome. When the body has ingested too much ethanol, normal liver function may be interrupted, leading to a chemical imbalance and disruption of homeostasis. The development of the liver's inflammatory response can be a result of several complications during the metabolism of alcohol. During the ethanol to acetaldehyde conversion, there can be a buildup of reactive oxygen species. As the name implies, they contain oxygen and are superreactive. An example is hydrogen peroxide. When ROSs come into contact with various components of the cell, like proteins or DNA, serious damage can occur. Another problem arises when acetaldehyde binds to macromolecules, enzymes, the cell membrane, and other compounds in the cell, creating acetaldehyde adducts. This can disrupt the cell from performing its regular functions. The immune system recognizes these acetaldehyde compounds as foreign, and antibodies are produced to attack the hepatocytes. Lastly, compound NAD+ is converted to NADH when used with the ADH enzyme to break down ethanol. As more ethanol requires conversion, more NAD+ is used up, resulting in an increase in the NADH byproduct. Very generally speaking, the ratio of NAD+ to NADH is very important in regulating many biochemical functions of the liver. When there is an imbalance, the liver signals the cell to stop breaking down fatty acids and begin synthesizing fatty acids. In most people, fat in the liver can be harmless, but for other people, this can lead to steatosis, aka fatty liver, characterized by the liver becoming large, heavy, greasy, and tender, which can lead to inflammation. Women have a higher risk of developing alcoholic hepatitis because they process alcohol differently. This could be due to women having less water in their bodies, higher proportions of body fat, and less of the enzyme dehydrogenase, all of which cause women to have a higher blood alcohol level than men. Another risk factor is the amount of alcohol you consume. Binge drinking, so consuming 5 or more drinks at one time, might increase your risk. Some of the signs of alcoholic hepatitis are jaundice, which causes the yellowing of the skin and whites of the eyes. This is due to the bilirubin from red blood cell degeneration not being efficiently processed in the hepatocytes, causing it to circulate in the bloodstream and deposit in the tissues. There also can be confusion and behavioral change due to the buildup of toxins that are normally broken down and eliminated by the liver. These toxins can cause damage to your brain and, in severe cases, result in a coma. The most effective treatment for alcoholic hepatitis is to simply stop drinking. In summary, proteins are important for metabolizing alcohol. When too much alcohol is ingested, the liver's ability to function can be impaired, resulting in a disruption to homeostasis. This leads to the development of an inflamed liver, causing alcoholic hepatitis.